Elasticity has something to do with the stretching or the compression of a body when a force is applied onto it. If you can change the shape of that object upon the application of force, that comes under elasticity. So if we apply a stretching force, it would increase the length of the object, and when we remove that force, it must come back to it. It must not cut to word use करेंगे. It come back to its initial shape. So if a certain body has this property, we called it an elastic object. That upon the application of compressive and stretching force, the object stretches or compresses. Stretching में क्या होता है? The length of the object increases, and compression में क्या होता है? The length of the object decreases. But upon the removal of the force, the object comes to its original shape. So we can write it as due to force application, the force could be both stretching and compressing. ठीक हो गया? स्ट्रेचिंग एंड कंप्रेसिव फोर्स की वजह से, स्ट्रेचिंग फोर्स से जो लेंथ है वो इंक्रीज, original length would increase, and original length would decrease. But again, this is only the under the influence of this force, as long as these forces are applied. Normally, अच्छा अब यहाँ पे ना टू टाइप्स ऑफ ऑब्जेक्ट्स होते हैं, एक इलास्टिक ऑब्जेक्ट्स होते हैं और एक मतलब जैसे रबड़ रबड़ होता है हमारे पास. अब देयर इज अ टर्म नोन एज प्रोपोर्शनैलिटी, लिमिट ऑफ प्रोपोर्शनैलिटी. लिमिट ऑफ प्रोपोर्शनैलिटी बेसिकली हमारे पास ये होती है कि इसको वो भी बता देता हूँ. As a maximum force that an object could endure without permanent change in shape, limit of proportionality. I totally forgot that I have written all these things in the inverted form. Anyhow, limit of is the maximum force an object can withstand without permanent change in shape. So that is limit of proportionality and the maximum force an object can. That is कि हम लोग जब ये force remove करें, the object should come to its original shape. For example, if its original length was 10 centimeter, and upon the application of stretching force, it came out to be 12 centimeter, or upon the जो है compressive force, it becomes 8 centimeter. After the removal of force, if it come back to this original length, that force is known as, that force is not, it's not the force that we name as limit of proportionality, it's just the maximum force that an object can withstand without permanent change in shape. Anyhow, getting back to the basics of this chapter, जिन्होंने यहाँ पे discuss किया है कि matter has a certain, is made up of atoms and molecules. Do you know how object stretches or compresses? Because when we apply force onto an object, the layers of atoms slide past each other. That is how we get the changes in shape. इस तरीके से ना. So matter is made up of small atoms and molecules. Applying external force like weight, pressure, or heat causes a deformation of matter, which in turn changes the shape, dimensions, and orientations. Solid matter is made up of atoms and molecules. Least जो compressing या stretching होती हैं, that is in solid because उसके atoms fix होते हैं at its position. Liquids भी compressive, उनकी compression काफी comparatively less होती है. The most compression occurs in compression or stretching occurs in terms of gases. Cause वो easy उनके अंदर spaces between the atoms बहुत ज्यादा exist कर रही होती हैं. Okay, let's just stick to the topic first. Here. Solid matter is made up of atoms and molecules which are packed closely. The intermolecular space between the atoms is significantly less than in liquids and gases. Spaces वही जो मैं भी आपको बता रहा था ना कि if this is the solid structure, so the particles are very tightly packed with each other. So there is not much uh, to be done with these particles. Because of this property, they retain their original shape easily. But obviously in solid, there are certain materials जिनको हम compress and stretch कर सकते हैं. That is why they are known as elastic objects. Even being solid. So उनकी structure के अंदर कुछ इस तरह की changes आती हैं कि वो they could be. Whereas in case of solid and liquid, atoms and molecules are loosely packed and the deformation of this matter takes less force as compared to the solid. Liquids and gases do not retain their equilibrium unless an external force is applied again. For example, if you have applied a force on liquid to make it come back to its original shape, you need to apply the force again. तो वो ये यहाँ पे बात कर रहा है, इस पॉइंट को रिपीट कर रहा है कि once liquids and gases do not retain their equilibrium state unless an external force is applied again. Some examples includes stretching rubber band and shown and metal rods जो होते हैं हम इनको stretch कर सकते हैं. But you know कि there are certain metals जिनको अगर आप stretch करें so they retain their particular shape. This means कि हमने force, we have applied force bigger than the limit of proportionality or ये सब पॉइंट्स यहाँ पे आएंगे. Hooke's law is basically this is the limit of proportionality. This is what I was talking to you about. That is up till this point, if I remove the force, the object would come back to zero. Come back to zero, it means it will come back to its original shape. But if I applied force bigger than this, it would have a permanent change in shape. For example, if it was 10 centimeter, it was 12 centimeter. After removing the force, it would come back to 10 centimeter. But अगर मैंने limit of proportionality से bigger force apply किया है, now its new length would be 12 centimeter and it would retain into this position without even if I remove the force out of it. Okay. So Hooke's law is basically defined as Hooke's law को मैं खुद define कर देता हूँ. यहाँ पे formula नहीं दिया हुआ. Hooke's law is defined as force is directly proportional to extension provided limit of proportionality does not reach. What is limit of proportionality, Shirino? How do we define limit of proportionality? I cannot hear you.
It's the point at which stress and strain are directly proportional. I don't know.
Hamna, what is limit of proportionality? I'm not asking for an exact definition, just the concept of limit of proportionality. What is the concept of limit of proportionality?
It's the maximum point where an object can stretch.
Yes, we are applying force yes, we are applying force onto an object, and the maximum force the object can endure without permanent change in shape is known as limit of proportionality. Here we have certain few more definitions of limit of proportionality. The ability of a deformed body to return to its original shape and size when deforming force are removed is called elasticity, जो मैंने आपको बिल्कुल स्टार्ट में बताया था. ठीक है? When a stretch spring is released, it comes back to its original position. When a tennis racket hits a ball, the ball shape is distorted or deformed, but it regains its original shape when it bounces off the tennis ball. Similarly, when archer shoots an arrow, she bends and come back to this is again the indication of an elastic object. वही अब उन्होंने बात की हुई है कि not all material returns to the original shape when a deformed force acting on it is removed. Materials that do not return to their original shape after being distorted are inelastic objects. If the object upon the application of force is stretching and is not coming back to its original shape, it means either we have applied force bigger than the limit of proportionality or the object is non-elastic. There are two possibilities into that. Most materials, यहाँ पे बिल्कुल next उन्होंने वही point discuss किया हुआ है. Most materials are elastic up to a certain limit known as elastic limit. Beyond this elastic limit, a permanent change in shape is occur into that. ये उन्होंने example discuss की हुई है of springs of elastic ball. ये deformation हो रही है and ये archer की deformation हो रही है. These are all the elastic object because when the force is removed, they come back to their original shape. So Hooke's law is given as definition हम already discuss कर चुके हुए हैं. In terms of formula, it is written as F is proportional to X. Here X is the extension. Extension is defined as change in shape minus original length. जैसे अगर ऊपर डायग्राम पे हम लोग चाहें, यहाँ पे एक्सटेंशन क्या है हमारे पास, यहाँ से लेके यहाँ तक हमारे पास ओरिजिनल लेंथ है. ठीक है? This area, this is the extra length which is brought by this weight. So this X is this stretched length, इतना portion is extension. इसको X से denote करते हैं. इसमें कितनी extension होगी सेकंड वाले में? देखो ये अगर उसकी ओरिजिनल लेंथ है तो यहाँ से यहाँ तक इस एक्सटेंशन. Whenever Hooke's law is obeyed, that is F is proportional to X, extension linear होती है. For example, अगर original length was 10 centimeter, next length is 12 centimeter, तो उससे next length कितनी होगी? 14 centimeter, 16 centimeter upon the addition of weights. For example, अगर 2 Newton brought 10 to 12, तो 4 Newton कितना लाएगा? 14 and 16. You could see here the pattern is similar. 2 centimeter, 2 centimeter, 2 centimeter. And extension is always found out using subtracting it from its original length. So, यहाँ पे extension कितनी आ रही है? 12. यहाँ पे कितनी आएगी? 4. And then always subtract it from ये extensions है हमारे पास. ठीक है? Extension always found using change in length. This 12 centimeter is the change in length and 10 centimeter was the original length. Separate करेंगे, we'll get the values. Here, when we remove the proportionality sign, F is proportional to X, and when we remove this proportional sign, I get a constant K. This K is known as spring constant. And this K is equals to F over X, which means it has an inverse relationship with extension. What is the meaning of inverse relationship? Shrino?
Basically, when one thing is higher, the other thing is lower. I know how to
Yes, when
explain
one
it.
increases, the other decreases. This is what inverse means. So the springs with bigger values of K's means they would extend less. Okay? If someone would say that this spring has a bigger spring constant, this means upon the application of force, it would स्ट्रेचलेस। तो वो जो हमारी कार्स के अंदर एंड बाइक्स के अंदर शॉक एब्जॉर्बर्स होते हैं ना, दे आर मेड अप ऑफ such springs who has bigger K values. This all is written here as well. You can give it a read later. बाकी आगे एप्लीकेशन ऑफ हुक्स लॉज उन्होंने यूज किए हुए हैं बैलेंस व्हील स्प्रिंग स्केल के अंदर एंड हेयर स्प्रिंग इन galvanometer. Galvanometer is a device which is used to measure the value of voltage or current in a circuit. That's not something that you need to understand right now. Just memorize the application that it is used in balance weight. Spring scale basically weight measure करने के लिए use होता है. ये लिखा भी हुआ है यहाँ पे सारा कुछ. वो जब आप वॉचेस को स्क्रू करते हो ना, एंड जिस तरह टाइमर्स वगैरह के अंदर भी होता है, टॉयज के अंदर भी होता है, बेसिकली ये बैलेंस व्हील ऑफ द मैकेनिकल वॉचेस भी है, वही वाली चीज होती है जिसके आप अंदर आप स्क्रू करते हो उसको, एंड यू एंड द टॉय कीप्स ऑन प्लेइंग ऑन इट्स ओन. एक्चुअली आप यू कुड रीड इट ऑन योर ओन. एक मैं आपको रीड कर देता हूँ, which is a balance wheel is the time keeping device used in mechanical watches. It is weighted wheel that rotate backs and forths, being returned towards its center position by a spring, torsion spring or hairspring as shown as in figure 1. It is driven by the escapement which transforms the rotating motion of the watch gears into impulses driven by the balanced. ये वो balanced wheel के अंदर है. ये torsion हमारे पास वो है. this ये जो राउंड अप हो रहा है ना, दिस इज द स्प्रिंग, और यहाँ से इसको हम लोग क्या करते हैं, वो करते हैं, टर्न अराउंड करते हैं, जिसकी वजह से दिस कीप्स ऑन गोइंग बैक एंड फोर्थ. ये पूरा स्ट्रेच होके कवर्स दिस प्लेस, ये वाली पूरी प्लेस को कवर अप कर लेता है, देन इट कम बैक टू इट्स, बिल्कुल इतने एरिया में कवर अप हो जाता है, गोज बैक कम बैक, इस तरह होता रहता है. स्प्रिंग बैलेंस आई हैव टोल्ड यू कि ये वेट को मेजर करने के लिए यूज होता है, एंड गैल्वेनोमीटर के अंदर ये भी बेसिकली ना, गैल्वेनोमीटर के अंदर ये आपको यू कुड सी, मैं इसको थोड़ा सा और करता हूँ, ये स्प्रिंग आपको गोल्डन से नजर आ रहा है. दिस स्प्रिंग जो है इसकी इलास्टिसिटी को यूज करके हम लोग जो है ये पॉइंटर जो है इट इज मूव्ड अक्रॉस द, इसमें और भी बहुत सारे पैरामीटर्स होते हैं, बट बेसिकली यहाँ पे हम स्प्रिंग की इलास्टिसिटी को यूज कर रहे होते हैं टू व्हेन एवर द फोर्स इज रिमूव्ड, यानी सर्किट आप जब भी ऑफ करोगे द pointer would come back to its original position. So galvanometer is a device that is used for detecting current or voltage. It makes sure of the hairspring which not only electrical connections to coil and restoring the pointer back, but also make the deflections proportional to the force according to Hooke's law. These subelastic objects and these are used within the limit of क्या कहते हैं, elastic limit के proportional limit of proportionality के अंदर यूज होते हैं, so that wherever they are used they could bring back the pointers or the scale back to zero when there is no force applied. So उसने ये बड़ा important point लिखा है कि they all obeys Hooke's law because whenever it's not working it must stay at 0, 0 and 0 in its original positions. स्प्रिंग बैलेंस में भी एग्जैक्टली ये होता है, इसमें हम लोग स्प्रिंग यूज करते हैं जो कैलिब्रेटेड स्प्रिंग होता है, यानी ये जो है ना आपके, आप ये कुछ सी द स्केल है, ये कैलिब्रेटेड है प्रॉपर्ली हमारे पास. 0 1 when no weight is hung it means 0. अब ऑब्वियसली हमने इसमें सबसे पहले नॉन वेट्स रख के जो है ये जो है स्केलिंग की हुई है, इसको हम लोग कहते हैं कैलिब्रेट करना, कैलिब्रेशंस. दे आर डन यूजिंग नोन वैल्यूज फर्स्ट एंड देन उसके अकॉर्डिंगली हम स्केल्स यहाँ पे बिल्ड करते हैं. तो जैसे हम इसमें फोर्स अप्लाई करेंगे, यहाँ पे वेट हैंग करेंगे, ये पॉइंटर जो है वो डाउनवर्ड मूव करते रहेंगे, इट वुड टेल अस व्हाट इज द वेट ऑफ द ऑब्जेक्ट, और जैसे ही हम लोग यहाँ से वेट को रिमूव करेंगे इट वुड कम बैक टू इट्स जीरो पोजिशन. सेम गोज फॉर दिस वन, सेम गोज फॉर दिस वन. देयर आर सर्टेन लिमिट्स जब हम उसके अंदर करते हैं. इलास्टिक रीजन हमारे पास ए टू बी होता है, फिर हमारे पास प्लास्टिक रीजन होता है, दिस इज द फ्रैक्चर पॉइंट, यहाँ पे आके ऑब्जेक्ट टूट जाता है, अल्टीमेट टेंसाइल स्ट्रेस होता है, यूटीएस का नाम लेते हैं हम लोग यहाँ पे. दिस इज द लिमिट ऑफ प्रोपोर्शनैलिटी. दिस रीजन इज द इलास्टिक रीजन, क्योंकि यहाँ पे ऑब्जेक्ट अप टिल हेयर ऑब्जेक्ट वुड कम बैक टू जीरो, बट इसके बाद जो है वो परमानेंट चेंज इन शेप आ जाती है हमारे पास, एंड देन certain materials have other points as well. But according to elastic materials, it is split into elastic materials are further divided into two parts, ductile and brittle. Brittle वो होते हैं कि they break down after elastic limit and sometimes right after limit of proportionality. And ductile objects हैं आते हैं which could enter into plastic region and can be used to make sheets and wires. Because they could enter this plastic region, so they could be used to make sheets and wires. They might have given some of the examples as well here. हाँ ये दिया मैंने वो सारे points. Yeah. Point A is the limit of proportionality and point B is the elastic limit, the limit to which material shows elastic behavior, also called as yield strength. Point C is the maximum stress a material can bear before fracturing or wo ultimate tensile stress, and at point D the object breaks, fracture point कहते हैं इसको. Everything was written here. Good, I have not written it again. Do we have any questions so far up till here?
No.
Okay. Screen now. Okay. So we have elasticity here again, the definition, the property of a body due to which it could come back to its original shape is called elasticity. There's this term known as stress and strain. Stress is basically defined in respect to Hooke's law as well. It is defined as the force per unit area, which later on we will also study as pressure as well. तो उसमें हम दोबारा इसको recontact करेंगे. Stress is basically defined as the force that is applied per unit area. And the second term is it's a unit force as a unit of newtons and area as a meter of meter square. So newtons per meter square. And strain is defined as the change in length over original length. That is upon the application of force, the change in length, which मतलब हमने जब refer किया था, it was 12 centimeter upon 2 Newton force, and then 14 centimeter upon 4 to on at the top will have change in length divided by original length. Then we have Hooke's law. Hooke's law is defined as the strain produced in a body by stress applied. Obviously, strain is basically change in length over original length that will be produced by the application of some force. So stress over strain is known as Hooke's law as well. Hooke's law is particularly applicable to elastic objects only. Non-elastic objects और rubbers के ऊपर हम लोग इसको apply नहीं करते हैं. We need to keep that in our mind, which might be referred as a theory in the other part as well. Yeah. Hooke's law is applicable to all kinds of deformations and all types of matter that is solid, liquid or gas within the limit of proportionality. Limit of proportionality यहाँ पे भी शो की हुई है, elastic limit and breaking fracture point और breaking point यहाँ पे भी शो किया हुआ. When a stresses cross this limit called elastic limit, a body is permanently deformed and is unable to restore to its original position. इसको plastic deformation का नाम भी देता है. And later they have discussed the Young's modulus, which is not the part of our syllabus here. You would not need to get in contact. Sorry, do not reach out to that one as for now. Do you have any questions so far, Bacho?
No.
We'll start discussing pressure inshallah tomorrow. And what is pressure, the atmospheric pressure, the units, the formulas, the pressure in solid, the pressure in liquids. That would be our topic for tomorrow, inshallah. So whenever we discuss pressure in case of in physics, pressure is basically defined as the force that we apply on a unit area. But there is a relationship that we need to discuss when it comes to pressure and area, because pressure versus area have an inverse relationship. Force and pressure has a direct relationship, whereas pressure and area has an inverse relationship. So whenever it comes to force, pressure, we define pressure as the force per unit area, or the force acting normally per unit area is defined as the pressure. Pressure is given as P, it's force per unit area. We could clearly see that area and the pressure has an inverse relationship. If we focus on this diagram that we have right in front of you, why do the thumb pins go very easily into the wooden board or into something? Can you come up with some example justification to this? Why they can easily go inside the board
Is
with
a
even
small
with even
area?
a smaller force apply? Yes, because the area which is in contact with the surface is very small, and with a very less force, because since area has an inverse relationship with pressure, so if the area is small, with even a lesser force, larger pressure would be applied to the surface. It goes into the surface very easily. Similarly, uh, on the soft ground, we usually uses machineries or boots that have greater areas. The reason behind that is that where there is greater area, the pressure applied by the pressure would be lesser, so we could easily move around in the area where the ground is soft. Similarly, wearing heels, we cannot move in a muddy ground. The reason behind that, heel has a smaller area, and due to that smaller area, pressure would be larger. So it would be very difficult for us to move across the soft ground. So if we want to move across the soft ground, we need something that has a bigger area, so that could reduce the pressure easily. So when it comes to solids, pressure is given as force per unit area. Pressure has a unit of pascals. Force का unit क्या होता है Shirino? What is the unit of pressure? Force.
Unit of force? It's a
Unit
Newton.
for force. Units for force. And for area.
Area meter square.
So what will be the unit of pressure?
Newton area meter square.
Newton per meter square. ठीक है? Which is
Oh,
equals to pascals. If we go to our NPF book, pressure and again defined किया हुआ कि pressure is defined as force per unit area. It is given as force per unit area. It is pressure as a unit of pascals, which is equals to newtons per meter square. अब यहाँ पे डिस्कस किया हुआ pressure increase when the force on the specific area is increased, or when smaller area is subjected to a given force. So smaller area leads to bigger pressures. Why does a balloon burst easily when pricked with a pin, but not when we squeeze with a hand? Why is that? Without reading the theory. Because smaller area leads to greater pressure. So needle pin is smaller in area, it would give a bigger pressure, so the balloon would burst very easily instead of squeezing with the hand. This is what I was telling you about ki heels. With varying heels, we cannot move on a soft ground. We need some bigger flat surfaces, flat shoes we need in if we want to go to some softer areas. Like however, because weight of the body is considered a small area when the pencil heels shoe, as illustrated. So we cannot, and उन्होंने hurt भी कहा है कि body भी हमारी hurt होती है. Similarly, knife से easily cut क्यों हो जाता है meat, because the surface area in contact with the meat is very small. So by applying a very little force, we could cut the meat very easily. So the pressure in case of solids is given as force per unit area. The next topic that we have in this book is atmospheric pressure. What comes to your mind when we discuss about atmospheric pressure? What comes to
Um,
your mind?
pressure generated by the atmosphere.
Yes, pressure generated by the atmosphere. As I've told you like millions of times that when it comes to physics, just try to understand the meaning of the word. That would basically almost explain you what the topic is going to be about. So whenever we're discussing about the atmospheric pressure, it means the pressure applied by the atmosphere. But the question comes here, where does this pressure come? Any clues, Hamna? How does the atmosphere exerts pressure on us? Any clue about that?
No.
We have air particles in the atmosphere, we have dust and air particles in the atmosphere, we have gravity in the atmosphere. Okay? So when the gravity of the earth pulls these air and dust and everything that is present in the atmosphere towards its center, so due to that, an atmospheric pressure is exerted on the earth's surface. Why is that? Because it is being pulled down by the earth's gravity. Which is being pulled down? The air particles, the dust particles, and everything that is present in the atmosphere of us, these that is being pulled down by the atmosphere, sorry, by the gravitational pull of the earth, and that exerts pressure onto us. Normal atmospheric pressure is given as 1013 to 5 pascals, or we write it as 1.01 into 10 raised to power 5 Pascal, or 1.00 into 10 raised to power 5 pascals, 1 atmospheric pressure. This is a huge pressure. Why doesn't we get our bodies get crushed by by this pressure of the atmosphere?
Because our bodies also have pressure that's acting outwards.
Yes, very good, very good. Because naturally, our inside of the body is generating exactly, not exactly, but somehow closer to the atmospheric pressure. So the inside and outside pressure cancels out each other, and our bodies doesn't got crushed by the atmospheric pressure. So pressure is practically useful in dealing with liquids and gases. We are going to discuss the formula of pressure for liquids and gases as well. It's going to be different than the formula that we have discussed in case of solid. What was the formula in case of solid for pressure? What was the formula for solids? Anyone could answer it.
Force divided by area.
Area, force divided by area. अभी तो हम उसको रिव्यू करते हैं कि व्हाट इज एटमॉस्फेरिक प्रेशर, वो कैसे जनरेट होता है. मैंने आपको वर्बली बता दिया है. लेट मी वॉक यू थ्रू द थ्योरी दैट वी हैव इन आवर बुक. सो the pressure that an atmosphere exerts on the surface of the earth and all over the surface of the object on the earth's surface is called atmospheric pressure. Its value is given as 1013 to 5 pascals or newtons per meter square. So when atmospheric pressure is equal to this, or we have another unit for pressure which is bar, that's equals to 1.000 raised to power 5 pascals. ठीक है. आगे उन्होंने एग्जांपल्स डिस्कस की हुई है. जो सक्शन पंप होता है, व्हाई डज इट गेट जो है वो क्यों फिक्स हो जाता है ऑन द surfaces, syringes and straws, why are they able क्यों वो suck up कर देते हैं water? Now we know it is because of the difference of pressure. जब हम air suck out कर देते हैं तो inside pressure जो है वो less हो जाता है and outside pressure जो है वो bigger हो जाता है, जिसकी वजह से ये easily जो है water जो है वो suck up हो जाता है through the straw और through the syringe. और अगर हम suction pump की बात करें तो suction pump को हम जब push करते हैं, so that pushing जो है sucks back the air or sends out the air outside, so inside pressure becomes less than that of the atmospheric pressure. So due to that difference of pressure जो है it sticks to the surface. They might have written that is that we actually force the air out of the cup, allowing atmospheric pressure to hold it onto the wall. Ab outside pressure to this Suction cup is greater as compared to the inside pressure, so it will stick to the surface. The same thing is being applied to the when it comes to the straw and to the syringes. अब आप जब syringe को आप move करते हो तो basically आप air को क्या करते हो, suck out करते हो, जिसकी वजह से जो inside pressure is less than as compared to the outside pressure, तो इस वजह से water easily जो है वो suck up हो जाता है. Now the next important thing comes is के how can we find this atmospheric pressure? The apparatus that we use to find this atmospheric pressure is known as barometer. And in barometer, we use क्या कहते हैं, mercury in an inverted column. एक टब लेते हैं, we put mercury into that inverted column. उसके ऊपर एक हम लोग ग्लास जो है ट्यूब प्लेस करते हैं. After some time, we observe that there is some mercury up that glass tube, and it's not going up any further. So when we measured that length of the mercury in that glass tube, we came to know that 1 atmospheric pressure is equal to 760 millimeter height of the mercury in that column. So we refer to that height of the mercury in the column as the atmospheric pressure as well. That's how the barometer looks like. We have this tub in which we have mercury. This is the inverted glass column. After some time, we will observe that there is some mercury in this column. That is basically this area exposed to the atmosphere. It pushes down the liquid into the glass tube. So this height, here we have vacuum. This is vacuum. This height is basically the atmospheric pressure. So this height is equals to 1 atmosphere, and at normal condition, this height is equals to 760 millimeter of mercury or 76 centimeter of mercury. So we can also say that this height of mercury is equals to 1 atmosphere, which is again equals to 101,325 pascals or 1.0 into 10 raised to power 5 pascals. So this apparatus is known as barometer, and this barometer is used to find out the atmospheric pressure. So in normal conditions, the mercury height is 76 centimeter or millimeter. And whenever the pressure increases or decreases, clearly, अगर pressure decrease होता है, तो height would decrease, and if the pressure increases, the height would increase. ठीक है? So normally, जब storm आने वाला होता है, तो this height decreases, showing us that there is some decrease in pressure जिसका से storm या इस तरह की condition, bad weather conditions create हो रही हैं, and the one height approaches back to the normal और उससे थोड़ा सा increase होती है, that is an indication of a good weather. Clear? Are we clear what barometer is? Barometer is basically used to measure the atmospheric pressure. It looks like this. We have inverted glass column, tub with mercury in it. After some time, we will observe there is some mercury into this column, indicating some atmospheric pressure has been applied onto the surface. Okay. ये सब उन्होंने बताया हुआ है यहाँ पे जो मैंने अभी मेंशन आउट किया था. 1 atmospheric pressure is 760 millimeter, which is 101,325 kilopascals. मतलब पॉइंट वो साइंटिफिक नोटेशंस की बात ही हो रही है. अगर आप 101,325 लिखते हैं, सॉरी 101,325 pascals is basically this. अगर आप इसको साइंटिफिक नोटेशन में लेके जाएंगे तो 101,325 किलो पास्कल्स बन जाएगा. और अगर मैं इसको 1.0 लिखता हूँ तो इंटू 10⁻⁵ पास्कल्स बन जाएगा. चॉइस इज योर. आप जिस भी साइंटिफिक नोटेशंस के अंदर उसको ले जाना चाहें, दैट इज टोटली यू. 760 मिलीमीटर ऑफ Hg की बजाय 760 टॉर भी लिख सकते हैं. दैट इज अगेन द इक्विवेलेंट टू 1 millimeter. एंड दैट इज 1 टॉर is equals to 1 millimeter of mercury. So this is also a unit of pressure. In the next section, they have discussed about the heights, altitudes, and everything. उनकी applications क्या होती हैं, that I've explained to you earlier. K whenever we discuss about that. And लिखा हुआ mercury parameters are precise, but they are harmful. We know that mercury is toxic in nature to human body. So they are accurate, but they are toxic at the same time. So we avoid that. But barometers की जो applications होती हैं वो weather applications भी हो सकती हैं. We have we use an altitude measurements. Altitudes का मतलब when, अब ये तो clear सी बात है ना. In the when we're going to discuss the formula for the liquids, pressure in fluids, now we'll get to know that as the height increases from the surface of the earth, that is sea level से height increase होता है, the atmospheric pressure starts to decrease. So जब हम heights के ऊपर जाते हैं, that is माउंटेन एरियाज के अंदर, वहाँ एटमॉस्फेरिक प्रेशर डिक्रीजेस, थिन एयर होती है वहाँ पे अवेलेबल, ऑक्सीजन इश्यूज होते हैं, इट्स डिफिकल्ट फॉर अस टू ब्रीथ. सो डिफरेंस ऑफ हाइट्स की वजह से प्रेशर्स के ऊपर, एटमॉस्फेरिक प्रेशर्स पे जो है वो चेंज आता है, एंड वी यूज दैट इनटू आवर एप्लीकेशंस. Liquid barometers can estimate altitudes as atmospheric pressure decreases with increasing altitude. The height of the mercury column decreases, allowing for altitude calculation. These essential instruments in variations for altitude weather forecasting में भी use होते हैं. Falling barometer may include the approaching of storm, while rising barometer का rise का basically height in the barometer को discuss कर रहा है. Okay, is in the improvement in the conditions. इंडस्ट्रियल एप्लीकेशंस में आ जाता है कि लिक्विड बैरोमीटर्स जो अगेन प्रेशर्स को यूज करने के लिए यूज होते हैं. अगर सर्टेन हाइट से ज्यादा प्रेशर या कम प्रेशर है तो क्लियरली उसके अंदर हमारे पास जो है वो वी नीड टू सेट द पैरामीटर्स अगेन सो दैट प्रेशर जो है वो रिक्वायर्ड वैल्यू के अंदर ही रहे. हम अब आगे से एटमॉस्फेरिक प्रेशर डिक्रीजेस एज वी गो अप ऑन द अर्थ सरफेस, और फिर ऑक्सीजन लेवल काफी डिक्रीज हो जाता है. दैट इज बेसिकली इट्स वेरी डिफिकल्ट फॉर अस टू ब्रीथ इन दैट कंडीशंस. और वो स्ट्रॉ एंड स्टिच की जो एग्जांपल आपको डिस्कस की थी वो ये डिस्कस की हुई है कि एटमॉस्फेरिक प्रेशर हम उसमें डिक्रीज करते हैं इनसाइड द स्ट्रॉ बाय सकिंग अप द एयर, जिसकी वजह से आउटसाइड प्रेशर जो है वो इंक्रीज हो जाता है और बॉटल इजीली जो है वो स्ट्रॉ के थ्रू ऊपर आ जाता है. अब ये बहुत इंपॉर्टेंट शॉर्ट क्वेश्चन है कि व्हाई इट इज डिफिकल्ट टू कुक फूड एट हाई एल्टीट्यूड. वहाँ पे प्रेशर्स कम होता है, ऑक्सीजन लेवल कम होता है, तो इट्स डिफिकल्ट फॉर जो है वहाँ पे फूड को कुक करना. सो जिसकी वजह से हम प्रेशर कुकर्स को वहाँ पे यूज करते हैं, बिकॉज दिस विल हेल्प अस टू कुक द फूड फास्ट, बिकॉज उसके अंदर प्रेशर जो है वो काफी ज्यादा हो जाता है. As altitude increases and atmospheric pressure decreases, the boiling point of the water decreases. To compensate for the lower boiling point, the cooking time must be increased. Turning up the heat will not help cook the food. We need to give it a larger time because at heights pressure decrease होने से boiling points जो है वो हमारे पास वो भी क्या हो जाते हैं, decrease हो जाते हैं, and it will take longer for food to cook now as compared to that of the before. स्ट्रेंच के अंदर भी एग्जैक्टली सेम एग्जांपल ही है यूज हो रही है. आई एक्सप्लेन यू द फॉर्मूला दैट वी हैव फॉर के डेरिवेशन ऑफ द फॉर्मूला फॉर लिक्विड बैरोमीटर्स. यहाँ पे ये हाइट उसने यहाँ पे यूज की हुई है. सक्शन पंप्स के अंदर ये जो हमारे पास वैक्यूम क्लीनर्स होते हैं उनमें भी ये होता है कि फैन इन द वैक्यूम पंप लोअर्स प्रेशर इनसाइड द बकेट, जिसकी वजह से इजीली जो डस्ट एंड अदर पार्टिकल्स एंड दे आर सक्ड इनटू द बकेट. बाकी you could memorize this at a 30-kilometer height, atmosphere pressure becomes 7 millimeter of Hg, which is approximately only 1000 pascals. It will become zero at an altitude where there is no air, and we can determine the altitude of the place by knowing the atmospheric pressure at that place is approximately zero हो जाएगा. बाकी with respect to the atmospheric weather conditions पे हमने pressures को discuss कर लिया हुआ है. And pressure always acts in all direction. This is an example. एक certain direction में act नहीं कर रहा होता बल्कि pressure acts in all the direction every time. Okay, give it a read now. First of all, I will ask you about two formulas, and what is the बल्कि three formula. What is the formula for pressure in solids? हमना pressure in solids given as
Force divided by area.
Yes. And what is the formula? Another formula for weight or force? F is equals to W is equals to
Mass multiplied by
gravity, G.
yeah,
Okay. And Shireen, what is the formula for density?
Mass or volume.
And mass would come out to be density into volume. Let's put this M into this formula and we'll have F is equals to density into volume into G. Okay? Are we clear up till here?
yes.
So now pressure is equals to force per unit. Force came out to be rho into G into V over area. Okay? We can put volume as equals to area into height also. ठीक है? Because area is basically length into base होता है, into height कर देते हैं तो वो volume बन जाता है. If we put that into this formula in place of V, we'll have A into H over A. This area will cancel out with this and pressure would come out to be rho GH. This is the pressure, sorry, this is the formula for pressure in liquids. Do you understand it? Let me walk you through it again quickly. Malab, we are familiar with these formulas that F is equals to W is equals to mg and pressure for solid is equals to force per unit area. We are familiar with the formula of density, which is equals to mass over volume. I got the value of mass as density into volume and put this into this formula, which is F is equals to W is equals to mg. It came out to be rho V into G. I also know that volume basically is equals to area into height because area is given as base into length into base into height कर देते तो volume बन जाता है. So I wrote that in place of V, which was A into H. A got cancelled with A and we got the final formula for the pressures in liquid. We also have a neat version of this somewhere. क्या neat version क्या है सामने यहाँ पे दिया ही हुआ है. You could see that here as well. F is equals to W is equals to mg. Density is equals to mass over volume. Volume is equals to area into height. Putting this into this V, will have mass is equals to rho A into H. Force की value क्या आ जाएगी हमारे पास rho AHG. Put it into this equation and we'll have pressure is equals to rho GH, which means the pressure in liquid depends on which factors, Shrino? On what factors the pressure depends in liquids? Do you understand my question?
Says here the pressure in liquid is due to its weight, but I don't know the factors.
Matlab, the formula basically tells us the factors now on which it depends. What is the formula for pressure?
So, formula for pressure, it's the
Hamna,
it depends on
Force divided by area.
for liquids, I'm asking for liquids. अब हमने जो recently formula derive किया है, उसमें the pressure is coming out to be equals is equals to what? It's it's written in front of you
the
too as well. It's written right
liquid's
in front of.
density,
Yes, depends on what factors.
and it depends on
It
the
de
density and height and
the gravity. ठीक है?
and
So if we discuss about if we take this into account, the density of liquid is the density of liquid changing throughout this in इस container में density change हो रही है liquid की किसी भी point पे?
No.
Do we have any change of G here? Gravity की value within the earth's surface constant रहेगी. This means density and gravity normally is same. So at which point the pressure would be maximum? As it would point A, B, or C, where the pressure would be maximum?
Point C.
Because the greatest height is at point C. So from since the G is same, the greatest height is at point C. So we could see here the water is going further away from this point. So as the height from the surface increases for the liquid, the pressure increases. For example, someone is swimming at this point, pressure would be low. It start increasing at it going down. Okay? So pressure for solids and pressure for liquids, do we understand it? And do we understand everything about the atmospheric pressure and its properties? So let me ask you one simple question. If the pressure is decreasing, what does this indicates? If the pressure is decreasing, in terms of weather, what prediction does it give you of the pressure of the weather? If the pressure is decreasing,
Bad weather, like rain.
yes, storm or rain. And if the pressure increases from the atmospheric pressure, we have studied that if the pressure decreases, this is an indication of a storm or bad weather. But if it reaches to the normal atmospheric pressure or the greater than the atmospheric pressure, this is the reason. This is the condition for a good weather. What is the normal value of atmospheric pressure in terms of mercury? Which height of mercury respond to the atmospheric pressure? Correspond to, sorry. Anyone could answer. Now
I don't know. I think a sea level.
76 millimeter or 760 millimeter, 76 centimeter of Hg is correspond to atmospheric pressure. ठीक है? And again, pressure acts in all direction, whether it's liquid or solid, वो तमाम directions के अंदर act करता है for gases. And this formula could also be applied for gases as well. The next topic that we're going to study in this chapter after the atmospheric pressure and pressure in liquids is manometer. Manometer is a device which is again used to find out the unknown pressure. For example, we want to find out the pressure of a gas or of anything. We can use manometer. Manometer basically correspond to a U-shaped U-shaped tube होती है. At one point we apply the pressure which we need to find out, and second पे हम जो है एक known pressure रखते हैं. Wheresoever the height of liquid is less or low, difference of height उसमें calculate करते हैं and हम उसको pressure of that find out. For example, if this is the manometer, I normally make my students to understand this like this. Here is the atmospheric pressure. और यहाँ से हम लोग गैस प्रेशर दे रहे हैं जिसको हमने फाइंड आउट करना. ठीक है? एट नॉर्मल कंडीशन जो लेवल ऑफ लिक्विड होता है इट्स इक्वल ऑन बोथ लेवल. वेल हमने जहाँ से भी गैस को इंटर नहीं किया, the level of liquid would be same on both sides because it's equal to atmospheric pressure. But as soon as I apply the gas pressure here, I would see the difference in the liquid here. If, for example, it came out to be like this. यहाँ से यहाँ पे, सॉरी, ठीक है। अब हमें बेसिकली ये वाली जो हाइट होती है, जो डिफरेंस ऑफ हाइट आता है, हमने इसको कैलकुलेट करना होता है। इफ द हाइट इज ग्रेटर ऑन द एटमॉस्फेरिक प्रेशर साइड, इट मींस के द गैस प्रेशर इज ग्रेटर देन द एटमॉस्फेरिक प्रेशर। अब एटमॉस्फेरिक प्रेशर कितना होता है? 76 सेंटीमीटर। और ये जो हमारे पास हाइट निकलेगा, जो डिफरेंस ऑफ हाइट निकलेगा, उसको हम उसके अंदर क्या कर देंगे? ऐड कर देंगे। सपोज इट केम आउट टू बी 3 सेंटीमीटर, सो द गैस प्रेशर इज 79 सेंटीमीटर। एंड इट वुड बी अदर वे अराउंड, कि इफ द लेवल, अब इफ वी कुड सी हियर कि जहाँ पे हाई प्रेशर होता है वहां पे लेवल ऑफ लिक्विड कम होता है, जहाँ पे लो प्रेशर होता है वहां पे लेवल ऑफ लिक्विड क्या होता है? ज्यादा। अब इस पर्टिकुलर केस के अंदर हम लोग क्या करेंगे कि फॉर एग्जांपल अगर यहाँ पे एटमॉस्फेरिक प्रेशर होता, फॉर एग्जांपल आई एम सेइंग, इट्स यहाँ पे लिखा नहीं हुआ, एंड यहाँ पे गैस प्रेशर है। अब क्लियरली लेवल ऑफ लिक्विड यहाँ पे ज्यादा, इट मींस गैस प्रेशर इज लेस देन द एटमॉस्फेरिक प्रेशर। तो ये जो डिफरेंस ऑफ हाइट हमारे पास निकलेगा, इसको हम 76 में से क्या कर देंगे? सब्ट्रैक्ट कर देंगे। सो द प्रेशर वुड बी 73 सेंटीमीटर। डू यू गेट इट हाउ मैनी मीटर्स वर्क? डिफरेंस ऑफ हाइट हम कैलकुलेट करके उसको ऐड या सब्ट्रैक्ट करते हैं विद रिस्पेक्ट टू एटमॉस्फेरिक प्रेशर, इफ देयर इज एटमॉस्फेरिक प्रेशर ऑन द अदर साइड। ठीक है। अदरवाइज जो भी प्रेशर होता है उसके हिसाब से एक प्रेशर नॉन होगा, एक अननोन होगा, उसको हम लोग ऐड या सब्ट्रैक्ट करते हैं। ऐड कब करेंगे? व्हेन द लेवल ऑफ लिक्विड इज ग्रेटर ऑन द नोन साइड, एंड सब्ट्रैक्ट कब करेंगे? जब लेवल ऑफ लिक्विड इज ग्रेटर ऑन द अननोन साइड। आर वी क्लियर अबाउट दिस पॉइंट?
Yeah.
Shrinu, do you get it, or should I make another diagram?
Could you
Ki-
explain?
Manometer is basically a device which is used to find out the unknown pressure of the of anything. ठीक है? It looks something like this, U shaped होता है हमारे पास। एक साइड पे हम लोग कोई नोन प्रेशर रखते हैं, और एक पे जिस पे हमने जिसका प्रेशर फाइंड आउट करना है वो रखते हैं। ठीक है। नॉन प्रेशर नॉर्मली एटमॉस्फेरिक प्रेशर ही रखा जाता है। अब यहाँ पे हमने सिर्फ ये नोट करना है कि ऑन विच साइड लेवल ऑफ लिक्विड इज ग्रेटर। The side on which the level of liquid is large will have a less pressure, and the side on which the level of liquid is low would have a high pressure. That's it. That all you need to understand. Difference of pressure in calculations हमने यहाँ पे कहीं पे मेजर करने को बोली नहीं है, इससे हम लोग उसको डिस्कस नहीं करेंगे। ठीक है। So manometer is a device which is used to find out the unknown pressure to see. अब इस particular diagram में सिर्फ हम ये बता सकते हैं which side pressure is greater. वो भी कैसे हम बताते हैं? The side which will have lower level of liquid will have higher will have a higher value of pressure as compared to the one on which the level of liquid is greater. अब level of liquid यहाँ पे क्या है? ज़्यादा। This means कि यहाँ पे pressure कम है, and level of liquid यहाँ पे कम है, it means यहाँ पे pressure ज्यादा है। ठीक है। सिमिलरली यू कुड सी हियर लेवल ऑफ लिक्विड इज लेस। आपने ये डिफरेंस ऑफ हाइट कैलकुलेट करना होता है, ये स्ट्रेट लाइन बनाएंगे ना हम लोग, बिल्कुल ऐसे। ठीक है। सो हेयर द लेवल ऑफ लिक्विड इज ग्रेटर एज कंपेयर टू दिस वन। दिस मीन्स के pressure here is low and pressure here is larger. Similarly, like this, here we could see the level of liquid is greater as compared to this one. Again, the pressure is low. Acha, one thing we need to keep in our mind is that whenever we discuss about the pressure in liquids, the only thing that we need to we take into account is that pressure in liquids depends only on which three factors? What were the three factors on which pressure was depending? Amna?
Density, um,
Gravity
gravity,
and
and
height. So it doesn't matter what shape of the container is. ठीक है। The only thing we need to keep in our mind is कि density, gravity and height उसमें same है। We could see here कि same level of liquid is same on both sides, which means density is same, gravity is same. The only thing we need to calculate is now the height. So the side on which the height of liquid is greater means it will have low pressure, and the side on which height of liquid is less will have a greater pressure. Are we clear about the manometer now?
yeah.
1. 2. 3. 4. 5. 6. 7. 8. 9. 10. 11. 12. 13. 14. 15. 16. 17. 18. 19. 20. 21. 22. 23. 24. 25. 26. 27. 28. 29. 30. 31. 32. 33. 34. 35. 36. 37. 38. 39. 40. 41. 42. 43. 44. 45. 46. 47. 48. 49. 50. 51. 52. 53. 54. 55. 56. 57. 58. 59. 60. 61. 62. 63. 64. 65. 66. 67. 68. 69. 70. 71. 72. 73. 74. 75. 76. 77. 78. 79. 80. 81. 82. 83. 84. 85. 86. 87. 88. 89. 90. 91. 92. 93. 94. 95. 96. 97. 98. 99. 100. 101. 102. 103. 104. 105. 106. 107. 108. 109. 110. 111. 112. 113. 114. 115. 116. 117. 118
In the next part, they have discussed about the uses of manometer, and that is it is used to find out the pressure of fluids using mechanical properties of fluids, that is movement. It's also used to measure the vacuum, used to measure the flow of fluids, filter pressure, used to meter calibrations, measure leak testing. It's also used to measure the liquid present in a tank. With the pressure value of known pressure given by the liquid, we can also find out which type of liquid. If we have the pressure, we'll compare it with it. Pressure for a particular solution normally remains constant for a particular heights. Ideal cases के अंदर जो height होती है हमारे पास. बाकी comparison of manometer versus barometer ने दिया हुआ है. It is device used to measure the pressure of liquid, but that of liquid concerning with the Earth's atmospheric pressure. It is a device used to measure fluid pressure, but that of air, as it can differ with the distance when it blows or above sea level. जो हम लोगों ने कल पढ़ा भी था. If it's above sea level, pressure जो है वो less होगा, and if it's below sea level, pressure would increase. It comes in different forms. It is commonly only in one basic design. जैसे उसने यहाँ पे हमें दिखाया भी हुआ है कि U shape में भी हो सकता है, इस shape में भी हो सकता है, इस shape में भी हो सकता है. Barometer normally एक inverted tube की form में ही होता है. These are filled with mercury or heavy liquid materials, but in some cases they can be filled with the lighter liquids as well. In all that cases, they are only filled with mercury or any other heavy liquids. So comparison अगर कहीं पे आए, if there comes a question there where they ask us to find compare manometer versus barometer, so we have that in our table. The next topic that we have for today is the Pascal's law or Pascal's principle. पास्कल्स प्रिंसिपल की जो डेफिनेशन है, इट्स बेसिकली उसके हम एप्लीकेशन को डिस्कस करते हैं. बेसिकली पास्कल्स प्रिंसिपल की ये है कि लिक्विड जो है अप्लाई प्रेशर इन ऑल डायरेक्शंस इररिस्पेक्टिव ऑफ एनी वैल्यू. Let me take you there. Pressure applied at any point of a liquid enclosed in a container is transmitted without loss of to all other parts of the liquid. That's how we define the Pascal's law. Okay, for example, अगर हम यहाँ से pressure apply करेंगे on this container, equal amount of liquid will go out of, then the pressure exerted by all these points would be exactly the same. इसकी जो बेसिक एग्जांपल है वो हम लोग यूज करते हैं, एग्जांपल कहते हैं, एप्लीकेशन इसकी पास्कल लॉ की डिस्कस करते हैं इन केस ऑफ हाइड्रोलिक प्रेस के अंदर. हाइड्रोलिक ब्रेक्स में भी you have heard this term hydraulic brakes, या you must have seen जब कार वॉश के लिए जाती है, सो इट्स वो जो अप करते हैं उसको, अप द प्लेटफॉर्म करते हैं उसको विद द हेल्प ऑफ अ डिवाइस, वो बेसिकली हाइड्रोलिक प्रेस के केस में काम करी होती है. अब हाइड्रोलिक प्रेस के अंदर प्रेशर ऑफ लिक्विड्स एंड सॉलिड को एग्जैक्टली जो है साइड बाय साइड डिस्कस किया जाता है. हाइड्रोलिक प्रेस में बेसिकली ये होता है कि अगर इफ यू अंडरस्टैंड दिस डायग्राम, वेयर इज दैट पॉइंटर, ओके, उसमें बेसिकली हमारे पास टू outlets होते हैं, one with a smaller area and one with a bigger area. So if I draw this diagram in front of you, according to the pressure, अब यहाँ पे force क्या लगेगा? If we apply force here, ठीक है, here area is smaller, pressure यहाँ पे क्या होगा? Apply होगा, which will be shifted through liquid to this point, और यहाँ से कार को जो है वो लिफ्ट किया जाएगा. ठीक है, बट एज पर द लॉजिक गिवन बाय दिस के एंड पास्कल लॉ के pressure applied at any point of a liquid enclosed in a container is transmitted without loss to all of other parts of the liquid. So according to this point, pressure at this point and pressure at this point would be equal. तो जब हमने ये इंक्लोज कंटेनर है, हमने यहाँ पे प्रेशर जो भी अप्लाई करेंगे वो थ्रू लिक्विड सारा का सारा किस पे शिफ्ट होगा? टू दिस पॉइंट. ठीक है, सो अकॉर्डिंग टू पास्कल लॉ इट टेल्स अस दैट कि इन एन इनक्लोज कंटेनर, अब ऑब्वियसली यहाँ पे भी पिस्टन होगा एंड यहाँ पे भी पिस्टन होगा. आई विल शो यू अ बेटर डायग्राम सून. बस बेसिकली मैं कह रहा था कि यहाँ पे फोर्स F1 अप्लाई हो रही है एंड यहाँ पे फोर्स F2 थ्रू लिक्विड जो है वो अप्लाई हो रही है. दिस इज द एरिया A एंड दिस इज द एरिया A, capital A. So since it's an enclosed container and we have liquid here, so all of the force and pressure, which is force per unit area, would be transferred through liquid to this point, which would be equals to F2 over A. अब हाइड्रोलिक प्रेस के अंदर हम लोग इसी इक्वेशन का यूज करके वैल्यू ऑफ फोर्स भी कैलकुलेट कर सकते हैं। एरिया तो इजीली नोन होता है हमारे पास, दूसरी साइड पे हम लोग कोई भी अननोन फोर्स को यहाँ पे कैलकुलेट कर सकते हैं अकॉर्डिंग टू द लॉजिक। सो पहले हम एनबीएफ में देख लेते हैं कि हाइड्रोलिक प्रेस की उन्होंने इक्वेशन हमें क्या ड्राइव करके दी हुई है, एंड देन I'll टेक यू टू द अदर पॉइंट। हाइड्रोलिक प्रेस बेसिकली इन्हीं प्रिंसिपल्स के ऊपर काम कर रहा होता है, लाइक दिस। अब ये भी इनक्लोज कंटेनर है, तो यहाँ पे हम फ्लूइड के ऊपर जो भी प्रेशर अप्लाई करेंगे वो सारा का सारा किस में ट्रांसफर होगा, इनटू दिस वन। हाइड्रोलिक ब्रेक्स मोस्टली हैवी व्हीकल्स के अंदर भी यूज होती हैं। दिस इज द डिस्कशन आई वाज टेलिंग यू, सॉरी, द डायग्राम आई वाज रेफरिंग टू। ये कार वॉशेस में आपने नॉर्मली देखा होगा इस तरह की चीजें, राइट? This is the वो platform, this one with area A2, pressure P2 and force F2। अब यहाँ से जो हम प्रेशर अप्लाई करेंगे वो थ्रू लिक्विड सारा का सारा किस पे ट्रांसफर हो जाएगा, इस पॉइंट के ऊपर। अब यहाँ पे हमें लेसर फोर्स अप्लाई करनी होगी, बट उसके कंपैरिजन में हमारे पास यहाँ पे क्या होती है, एक लार्जर फोर्स क्रिएट होती है। एंड अगर हम पास्कल लॉ का फॉर्मूला देखें तो इट वुड बी समथिंग लाइक वही P1 इज इक्वल टू P2 वाला फॉर्मूला यहाँ पे लगेगा। एंड मैंने आपको ऑलरेडी उस डायग्राम के अंदर शो कर दिया था, काम नहीं थी मैंने वो डायग्राम, ये वाली डायग्राम। F1 into A and F2 into capital A, P1 and P2. This would be equals to each other according to the law, Pascal law. So अगर हमें F2 को कैलकुलेट करना है, we'll rearrange the formula, इसको यहाँ पे मल्टीप्लाई कर देंगे। So F1 is equals to area over area। ये जो रेशियो होती है हमारे पास is always greater than 1। Hence F2 would be larger than F1। Are we clear about the equation? Or should I drive it again? प्रेशर का फॉर्मूला क्या होता है, F ओवर एरिया। फॉर द स्मॉलर पिस्टन उसका प्रेशर क्या था, P1, which is equals to F1 over smaller a। This was shifted through the liquid to the piston 2, where the pressure was F2, P2, F2 over bigger piston। अब according to Pascal law, pressure transferred through liquid does not get lost anywhere, or all of the pressure is transferred all together। So अगर हम इस इक्वेशन को यूज करें तो P1 was F1 over smaller a and P2 was F2 over capital A। अगर हम इसको F2 को, विच इज द अननोन फोर्स, यहाँ पे तो हमने खुद अब फोर्स अप्लाई किया था ना स्मॉलर पिस्टन के ऊपर, यहाँ स्मॉलर पिस्टन के ऊपर तो हमने खुद फोर्स अप्लाई किया था, F2 फोर्स हमें कैलकुलेट करनी है। तो हम लोग F2 को सब्जेक्ट बनाएंगे, एंड F2 वुड बी इक्वल्स टू A over A into F1। This is the equation of hydraulic press। And since this area, suppose ये 2 सेंटीमीटर होता है, ये 1 सेंटीमीटर होता है, the answer to this ratio A over capital A over small a would always be greater than 1, which means when this will be multiplied with F1, F2 will always be greater than F1। This shows that K through liquids, if we apply pressure such that area 1 is greater then area 2, this is A1, this is A2, so F2 would be greater than F1 through the according to Pascal law and pressure of liquids। Are we clear about manometer, Pascal law, and the pressure of how to find the pressure of liquids? Do we have any question? Please give it a read and let me know if you have any question.